now we're going to take a look at solving problems that involve quadratic equations. Okay, so sometimes we can get a quadratic equation that can appear in a real life situation. In maths, this could be in relation to another topic, for example, Pythagoras, area of a rectangle, area of a triangle, etc. So to have success in these, then you have to make sure that you carefully read the question in order to fully understand what's being asked. Okay, because some of them can be quite mischievous in a way. All right. So example 8 says here a rectangle has sides x plus 7 centimeters and x minus 1 centimeters, as shown below. Find the value of x, given that the rectangle has an area of 48 square centimeters. So we know how to find the area of a rectangle. We can say that the area is equal to length times breadth. So that's going to be x plus 7 times x minus 1. And we know that that area is equal to 48. So I can say that x plus 7 times x minus 1 is equal to 48. Expand the brackets. So that would give me x squared plus 7x minus x minus 7 equals 48. Take the 48 across, because remember we can only solve a quadratic equation whenever the right hand side is equal to 0. So that will give me x squared plus 6x. Then it's minus 7, take away 48, which is minus 55. Okay. Now let's have a look and let's try and factorise this now. So 1 times minus 55 is minus 55. So it's quite obvious what that one's going to be. It would be 11 and minus 5. That's what would come together to give us the plus 6 when we add them up. So we're going to get x squared plus 11x minus 5x minus 55 is equal to 0. Many common factorise, many common factorise. So that will be x bracket x plus 11 minus 5 bracket x plus 11, keeping the brackets the same, equals 0. So we get x minus 5, x plus 11 is equal to 0. So x has to be 5, or x has to be minus 11. Now here's where the mischievous part of the question comes in. The question said find the value, singular, the single value of x, given that the rectangle has an area of 48 square centimetres. We've got two values of x, so we have to get rid of one of them. Think of the one that doesn't belong there. Well, we can't have x being negative 11, because if I was to sub that in, if I was to sub minus 11 into that, I would get minus 11 plus 7 on this side, which would give me minus 4. And you can't have a side that has a negative length. It makes no sense. So for solving the quadratic equation, that is the correct solution. But sometimes when it's a real life situation, you're going to have to just discard the one that doesn't belong. In this case, it's the x equals negative 11. So therefore, x is equal to 5. And make that clear to your examiner. All right. Let's look at the next one. It says a 5-meter ladder leans against a wall. The distance from the top of the ladder to the ground is a meter more than the distance from the foot of the ladder to the wall. The diagram opposite illustrates this information. I want to use Pythagoras' theorem to show that x squared plus x minus 12 equals 0. Now this is something that you will start to see a lot of, especially getting into higher maths, the show that question. So basically what part A is looking for here is us to use Pythagoras' theorem for this situation, and if we do it right, we should get x squared plus x minus 12 equals 0. Okay? So this should be the last thing that we see, so we don't use this to help us. That's what we should get to. So let me just do this down here then. So part A. So think of Pythagoras' theorem. It says c squared is equal to a squared plus b squared. So 5 squared is equal to x plus 1 squared plus x squared. So that's going to be 5 squared is equal to, and let's expand that bracket. So that will be x plus 1 times x plus 1 plus x squared. So 5 squared is 25 is equal to, and FOIL the bracket out, so we get x squared plus x plus x plus 1 plus x squared. So we get 25 is equal to 2x squared plus 2x plus 1. And then we'll take the 25 across. So we get 0 is equal to 2x squared plus 2x minus 24 equals 0. Oh, shouldn't put that in. Can't have two equal zeros in the one line. Let me swap the whole equation about. So I get 2x squared plus 2x minus 24 is equal to 0. Now, it doesn't quite match up what we need here. So, what do we need to do? We need to just divide the whole thing by 2. Remember, it's perfectly valid as long as you do the same to one side as you do to the other side. So it gives us x squared plus x minus 12 is equal to 0, as required. Okay. The whole point of a show that question in a maths exam is the fact that it allows us to, even if you're unable to make that work out, you can still use part A to then go and do part B. So it says, use this quadratic to find the distance from the foot of the ladder to the wall, and then from the top of the ladder to the ground. So basically just find the value of x. So what we really need to do here is we need to now just solve this quadratic. Let's go ahead and now just solve this quadratic. So that would be x squared plus x minus 12 is equal to 0. So 1 times minus 12 is minus 12. So the factors that would work out for that would be 4 and minus 3. So we'd have x squared plus 4x minus 3x minus 12 equals 0. Many common factorise. So we get x bracket x plus 4 minus 3 bracket x plus 4 equals 0. So that's going to give us x plus 4, x minus 3 is equal to 0. So x is equal to negative 4 and x is equal to 3. Okay, again, similar to example 8, we need to make the decision which value of x do we use. Well, common sense tells you can't have a negative length, so we actually physically just discard that. So we can say therefore x is equal to 3. So find the distance from the foot of the ladder to the wall. That's just the value of x. So part 1, foot of ladder to wall is equal to 3 meters. And part 2, from the top of the ladder to the ground, it's going to be x plus 1. So that's just going to be 3 plus 1, which is 4. So it's going to be 4 meters. Okay.